Good morning, everybody.
Good morning.
Morning. Oh, everybody's fresh.
Oh, yes.
It's good to hear.
As daisies. Yeah.
So, all ready for a new talk, I hope. And hopefully you had a good night last night. Not too late in the evening, that is. So, I'm going to talk about the GPU acceleration. The agenda is some introduction, of course, and we'll go through some testing and resulting I conducted, and then of course we're going to do a summary and see some takeaways on it. My name's Rasmus-Raun. I'm from Denmark, as my accent may be revealed, and I'm also a little nervous, as my pronunciation probably will reveal a little, so please bear with me a little. It didn't get that late for me last night, so I kept the beers at a low state. So that's not my excuse for not being quite fresh today. But I'll try to do my best to keep you awake and to hopefully give you some information. As you can see, I'm a part of the Team RGE group, a group of independent, how do you say, enthusiasts or nerds, geeks, a lot of names. You all know a lot of all the other members as well, so I will not dive deeper into this. I'm a part of the NVIDIA Grid Community Advice Program as well. It's like a CTA CTP program, but just for the NVIDIA Grid product. And I work with the Citrix primarily. I work in a company called Connecto, and we are specialized in the Citrix stack, so that would be everything. So from the mobile, share file, provisioning services, setups and desktop. Of course, also NetScaler, a lot of NetScaler. We are around 30 people and primarily focused on Citrix, as I said before, but we also have a Cisco startup, so we are aiming for the hardware stack as well, and networking stack. We also have some Imprivata people in our house, so we are trying to aim for the full user experience, because that's our focus, to have the full suite, to be able to optimize on each level, going from the networking stack and all the way up to the workflow stack with Imprivata, and of course everything in between. So, user experience, again, it's a topic well discussed, and I don't think we will get to a definitive answer, because everybody has their own way of thinking of user experience, but some of it, of course, is performance, and some of it can be workflows, some of it can be the graphical representation. If the user don't like the button is green, but they want a blue instead, if that can make their user experience bad, well, then it's another talk. In this session we'll focus on the performance talk. On the graphical side, we have some segments. The GPU virtualization was introduced by NVIDIA and their grid technology, and was primarily aimed for the high-end user cases, the use cases where there's no doubt that they need a GPU, because the application simply cannot function without the GPU. So that is kind of a no-brainer. No GPU, no application. So over time, the features, as we also see it with cars, new luxury cars, that over time the features tend to get extended to other segments as well. So these GPUs found their use cases not just for the designers and engineers, but also for people controlling the models, and for applications which may or may not directly rely on the GPU, but definitely can benefit, because some features get unlocked when having a GPU available. It still functions without the GPU, but certain features are not possible unless you have the GPU available. And then there's the normal, deadly, mortal people like me, just working in office and do a little browsing and, well, behaving normally, I would say. My girlfriend would disagree about me being normal, but that's another story. So, do they benefit from GPUs? Well, it gets to a discussion on good enough versus what is correct. And by correct I mean that all applications, that's me assuming something, but you cannot buy a laptop today without a GPU. You cannot buy a workstation today without a GPU. Even my phone has a GPU, so the GPUs are everywhere. It's not like I go to the supermarket and buy a computer and say, oh, I don't want the GPU, please take it out. It's not going to happen. So the developers, developing their applications of course, they're developing in environments where GPUs are often available, and they tend to use APIs, libraries, which directly or indirectly are utilizing the GPU via the operating system. So that for me is the correct way, because the application is developed in an environment with the correct resources. But we still tend to deliver a desktop without a GPU resource available to the users. So having the discussion on a physical laptop versus a virtual desktop, we have to keep in mind that the correct resources has to be available in both places, if we are to compare those, of course. And well, that's a long discussion. A lot of system administrators, they tend to think that my users, they definitely do not need a GPU because it's new technology. I know my CPU, I know my IOPS, I know my storage, I know my networking. No, I don't need GPU resources. But in the end, it's about the expectations, about the users expecting something, and about how to deliver and to fulfill those expectations. So for the office workers, I thought, well, I know they are utilizing GPUs, but how much? So I decided to do some comparison testing to see if these office applications are utilizing a GPU, and if so, by how much, how can we somehow correlate some kind of data to show the differences between having a GPU or not. So of course there's the scenario with the CPU only or no GPU, but also a CPU or GPU available scenario. And then at the same time it was obvious for me to also test the hardware acceleration on and off in the office applications, but also the software rendering feature in the browsing. So before I move on, I of course have to say that again, user experience is much more than just a resource question, or performance question. And these numbers are from a test scenario. So these are comparable or indicative, but they are not directly relatable to an enterprise environment. I'll get into that a bit later. A short recap of my findings last year, and I know there are a lot of numbers, but what you should notice is that this is Windows 7, Office 2013, and where we see the largest benefit is in the DWM process. I guess it's impossible to read the words from the back. I will read them. So the DWM process is the single process which gains the most of having a GPU available. The green bars are with a GPU, the blues are without a GPU, and then in between with and without hardware acceleration. So, since Windows 7, we of course have got a new version, Windows 10, and Office 2016, and a couple of login DSI tests have shown that just by changing the version of either the operating system and or the Office application, the user density gets lower because the resource consumption is higher. So to investigate in these versions, I built TestLab. It's actually my gaming PC that just got taken away from my son, so he's a bit mad at me, but I hope he'll live through it. It's a 4 GHz CPU, and I don't think that's quietly relatable to an enterprise environment, so I underclocked it to 2.3 GHz to mimic at least some kind of frequency. I know this is not an enterprise processor, so of course it's not like an apples to apples comparison, but at least frequency-wise, 2.3 GHz we see at a lot of customers. Yeah, 4 physical cores and so on. And an NVIDIA Tesla P4. It's a grid-capable Tesla card. Software side, built on Citrix because, well, that's where I have the most of my knowledge. Zen server because that has been in the vGPU game the longest time. So desktop version was, because at that time that was the newest version. I know there's been a newer version, 7.15. Newest receiver available at that time, and I tried to keep it as default, as out of the box as possible, so no tweaking, no optimizations, but like you would install it and just put it there and see how it performs. The virtual machine is typical standard VDI to vCPU, 4 GB of RAM, and it's machine creation services created, so non-persistent, meaning, of course you all know that, but every time we reboot, it gets back to its current original state. And a little note on the profiling, these vGPU profiles, I chose the P41B profile, that's the VDI profile. But a recap on how this vGPU resource management is scheduled. It's the GPU compute resources, they're time sliced, so it's, as we know it from the CPU, the hypervisor scheduling in of that resource. But the frame buffer is reserved, so it's actually the frame buffer that is limiting the amount of VMs available in a given vGPU profile. I've tried to be creative and use some colors. I hope it makes my message a little clear. So the versions, Windows 10, of course, it was the current business branch, or semi-annual, I think it's called now. Office 2016, obviously. A standard workstation VDA, assuming that a customer not knowing how to implement or how to optimize, they would just go for the standard VDA as well. And I did not have the need for OpenGL acceleration, so I thought that would be a good baseline, a good default. I was using Grid 5.0 tech preview drivers. I didn't see any bugs or any performance issues with this driver, so I kept going on. And it actually shows how long time I've been conducting these tests, because they are now pretty old. The newest version is Grid 5.1, as Jared mentioned yesterday, so quite some time has been spent on this. The session, Full HD, single screen, and I took the very high definition template. I deactivated the clipboard because in some of my workflows the clipboard is being used, and to not affect the test results, I deactivated this so that I would not, in my insanity, do some copy pasting in and out of this session. I also chose the adaptive display version 2 protocol, and the reason for this is the talk around still images versus moving images. We all know that H.264 is very good for moving images, but it's, at least in this context, it's not that good at text, because text is actually just defining small contrast in very small areas for our eyes to be able to perceive what is this letter actually, what kind of letter is it. But we still have a use case for moving images. So either we could just push a lot of still images through to give the imagination of like 24 frames per second, 30 frames or 60 frames per second. but that takes quite a lot of bandwidth. We could go to the H.264, which is very good at compressing moving images, but as I said before, it's not good at text. But this display protocol kind of gives the best of both worlds. It scans the session content and deciding what is moving images, and that part will be H.264 encoded. What is still images, pictures, that can be lossy compressed, and do you have text, then it can be lossless delivered to the endpoint device. So we get the best of both worlds with this protocol. And in my opinion, this is the best display protocol because it gives the possibility, especially for the office users who both uses or have the requirement of sharp text, contrast, but also have the need to have unified communication or to watch training videos and so on. So back to the methodology. I have based it on PowerShell scripting, of course, to be able to replicate the steps needed for the workloads. I am executing this one VM, one user on that VM on my host. So there's no scale out testing, there's no load testing. This is just one user, one VM. And I'm using PowerShell scripting also to collect the perform counters in the operating system. And for the frame counter, I was utilizing the WMI. The counters I was monitoring, of course, is the specific application process. How much CPU load is this particular process utilizing? But also the other processes as the TCXGFX, the encoding process, because that's, well, quite interesting when we're talking about graphics, of course. The TCXGFX is an indication on how much motion is going on to the screen that the Citrix session is sending to the endpoint device. Whereas the DWM, the Desktop Windows Manager, is an indication on how much is the operating system doing. Is it resizing a window? Is it doing some transparency calculations because of arrow user interface and so on in Windows 7? Oh, we're back.
That was the GPU crashing,
Yeah. Must be an AMD. And the frame counter, of course, is an indication on how fluid is this perceived. So the higher the frame rate, the more fluid, of course. I did 30 runs of this scripted workload. Word, Excel, PowerPoint, Internet Explorer, YouTube video. Not full screen, but in a windowed mode, or the browser was full screen, but the standard default where you have the video, I think it's around 75% of the screens or something like that. Because what we typically see at the end users are that they have this training video or unified communication not going in full screen, but they can have their Skype for Business as well, or another document open at the same time while watching the video or just listening to the audio of that video. So full screen video, of course, is one scenario, but this one is more like what we see at the customers, how they use it. And it's Internet Explorer 11, because we see a lot of customers stuck on this version because of legacy applications, ActiveX objects and so on. So I found that was a good baseline again to see how does it compare. And an idle website, why is that interesting? Well, I'm using a Danish stockbroking website, news website, and it has this banner on top which cycles through the different stock rates at a constant interval, and that introduces some heavy load actually on the CPU, and this is just idle. We have a specific customer, they have around maybe 200 concurrent users, having this idle web page just going in the background, opening it in the morning and then checking it continually during the day just to keep up with the news. But this of course consumes some resources. So that's the story on the idle scenario. And the scrolling is okay. They see that, oh, there are new headlines, so they just scroll down this the same site, this stockbroking news site, scrolling to the middle to see if there are any new headlines, scroll a little up again, reading, scrolling down. all conducted in a scripted behavior, of course, so I can reproduce it. From these 30 runs, I did a 95th percentile dataset, so a 31st run. And from this dataset, I was calculating the average values and noting the peak values. The reason for the 95th percentile was to make sure that a rogue process would not ruin or affect my data too much. So, going on to a little more graphics. This is a word scenario. You have the time on the x-axis. On the left you have the percentage CPU load. On the right you have the frame rate counter. The blue line, it's distinguishable, is the frame rate. So that correlates to the right side, but all the other graphs correlates to the left side, the CPU load. The blue area is the particular process. In this case, it would be the WinWord process. On top of that, you see the encoding process, the orange area. And again, on top of that, you see the desktop Windows Manager, and you have a total CPU load, the black line, which is more of a guideline for me to see that the system is not overutilized at that current moment, and that overutilization would affect the readings of the other processes. So the total CPU load I will not focus that more on. It's just as a guideline to show that the environment is not overutilized. So getting into some comparable figures. Looking at the WinWord process, between having a GPU or not, it doesn't seem to care that much, at least seen from the CPU usage load side. And hardware acceleration on or off doesn't seem to make any difference either. The encoding process, well, again, it's the same for all 4 scenarios, but the desktop Windows Manager process is really getting happy about having the GPU to do the heavy lifting of creating the graphics. And just to recall, the desktop Windows Manager was the operating system itself. So this is an indication of Windows 10's ability to offload its graphical use load. And, well, frame rate, it's constantly, because the default frame rate limit in the default HDX policy is 30 frames per second. Jumping on to Excel, well, Excel is pure calculations, so it's just CPU load. As before, we have the specific process, which is, in this case, is consuming almost all of the CPU resources. And on top of that, we have the encoding process and the desktop Windows Manager. Calculating on this data as well, the Excel process itself, and in this case also the TTXGFX, doesn't care whether it's hardware accelerator or not, or having a GPU or not. But Windows is still very happy, even though this is just an Excel spreadsheet. It's just calculations. There are a little graph making from the data, but it's just an Excel. But it's getting offloaded quite a lot by having a GPU. PowerPoint, also quite heavy on the CPU. As before, the specific application process, CPU load. Going on to the comparisons. The funny thing is that, again, as before, I'm repeating myself with the DWM process. It really likes the GPU. But looking at the frame rate, it seems to be lower with when having a graphics accelerator available. I can't explain why, but that was at least my findings in this scenario. Moving on to YouTube video, we see that the encoding process, the CTX-GFX process, is very active in this scenario at least. Of course, we have during the time period, it stays quite constantly because the frame rate and the motion on the video is quite constant. So, getting some data here, we see that having a GPU on the Internet Explorer process offloads the CPU quite a lot, unless you do not configure it correctly. You see that actually when having the GPU but using software rendering, the Internet Explorer process is utilizing more CPU cycles than when not having a GPU available. But as soon as we enable the hardware rendering, then it drops significantly. And this is because when we are enabling the hardware rendering, we are utilizing the NV decode portion of the Tesla card, so we are making the graphics card doing the decoding of the H.264 video from YouTube. And of course that offloads the CPU by quite a lot. Looking at the encoding process, it's happy to have a GPU. Of course it offloads it gets offloaded. And there's no difference whether the software rendering or hardware rendering is active or not. And again, the desktop Windows Manager, it's very happy of having a GPU, and it's even more happy when the NV decode can be enabled as well. So we see it drop from 19% to just 2% CPU load. And the frame rate, well, it needs to be as constant as possible for the perception of the video to be fluent, of course, so the higher the frame rate, in this case, the better. So, moving on to this idle web page, these spikes that you see here are this banner on top of this the page, which is refreshing every 10 seconds or 15-20 seconds or so. But it's like, you see it spiking around 40% each time, and multiply this by 200, then of course it becomes quite obvious that this is quite a CPU hog. When we look through the numbers, again we see for the specific Internet Explorer process is more CPU consuming when having a GPU as compared to when not having a GPU. But looking at the encoding process and a little bit for the desktop Windows Manager, that rise we see when having a GPU is more than paid for by the offload of the encoding process instead. And again, the funny thing, the delivered frame rate is somehow lower with the GPU and with the hardware acceleration of the decoding enabled. I can't explain why. I have a theory that this adaptive display is somehow kicking in, and I would like to be able to see what is the ratio of H.264 encoded content versus the still image, just like a ratio to tell like 1/3 H.264 and 2/3 still images. So that may explain how much of the screen in each case is H.264 encoded and how much is delivered through still images, but maybe CTEC will provide that sometime, or maybe not. So the same web page, but scrolling down. Of course, we see a large CPU load when scrolling, and the drop is where the user is supposed to read headlines. Scrolling a little up, reading, and scrolling down again, and then you see the spikes again because the banner then kicks in because the web page is idle. Summarizing, a spike again or a rise of the Internet Explorer process when having a GPU, but that is compensated for by the other processes. So altogether it's still a positive offload of the GPU, or the CPU, sorry. So, taking all this into account, we see that for the word process, the CPU is offloaded by up to 22 percentage points, and Excel 16, and PowerPoint 15%, at least in my test cases. So Office seems to be happy about having a GPU, and Windows 10 of course. Going on to the Internet Explorer 11, we see of course in the video scenario it's even more obvious that the GPU really benefits the CPU load on the host by quite a large margin. What I was surprised about was this idle, or this web page, how much resources it was consuming just by standing idle. It might as well be some commercials or advertising or anything else moving around all these, how to put it in a nice way, web pages who are sponsored by advertisers. But it just takes a very large toll on the CPU resources. But some of that toll can be offloaded by the GPU. And all these CPU resources, well, what can we use them for? Well, we can of course use them for having larger user density, more users per box, and having the same user experience. Or we can decide to give the users the headroom they need, or headroom for future upgrades. Office 2019 is just around the corner. My assumption is that it's going to be even more resource. I don't know, but I think it also points in the direction of the user demand, that users are expecting to have new graphics interfaces. We see it with our mobile phones as well. So we can deliver a better user experience by freeing these CPU resources, because, as I said in the beginning, user experience is not just about graphics performance, but it's also about getting a steady network line, getting data delivered, having some backend data that needs to be fetched and delivered to the user. So the CPU has a lot to do. So the CPU offload is, in my opinion, a quite significant parameter in this GPU talk, in this graphics talk. And it's not a subject I have seen been diving that deep into. So, and the last part I mentioned here was that what else we can do with these free CPU resources. By conducting more compression on the session, we are able to either deliver a larger resolution to the end user using the same bandwidth, or we can cut the requirements for bandwidth to the specific use case. So it's all a matter of options. But there's more offloading. We talked about the adaptive display version 2, that it was scanning the session and deciding what parts of the content should be H.264 encoded. There's, on the graphics cards, there's an NVENC. You have heard about it if you attended the NVIDIA session yesterday. But it's offloading the CPU on this H.264 encoding. If that was applied in my test scenario, I could cut off additionally 34% of CPU load. Unfortunately, the adaptive display V2 is not able to get hardware offloaded to the NVENC engine. But that would be a nice add-on. And as I mentioned with the Internet Explorer, the NVDIC or NVDAC, the decoding, hardware decoding of video is accelerated when we are utilizing the parameter or the setting on the do not use software rendering. Yeah, Microsoft's way of telling how to hardware accelerate. So, but if you want to know more and hear more on display protocols, but also on these offloading, then please attend Bram Wolf's and myself's presentation later on. I don't know if the time will probably not fit, so it's going to be Central European E2E time. So the takeaways.
Flexible time zone.
The takeaways from this is that the GPUs, it's not just a talk about graphics, because, well, we have the offloading for one, and as Jared mentioned yesterday, there's also the thing on CUDA or compute to be able to do that thing. And we're talking about user experience. Of course, graphics is one, but user experience is much more than just that. But graphics being a quite significant part of it. And I would dare to say that all user types can benefit from a GPU. Not just the graphical rendering, the accelerated showing of graphics, but also because of the CPU offloading. And to conclude, some fun facts. I have been spending a lot of time on this, learning a lot, consumed a lot of coffee, So, if anybody has any questions or comments, then please feel free. I think I have like 4 minutes left. Yeah.
Just a couple of observations and kind of questions really. I've spent a long time looking at something similar for a large bank who wanted to use ZenApp on Moonshot actually, which is obviously has a GPU in. Did you do any tests around perceived user experience? So,
no.
Because it's obviously it's great having the numbers, but if it doesn't actually make any difference to user experience, in terms of does it feel quicker? Does it respond better? Does the graphics display quicker? Then it's very hard to kind of put this in perspective as to is it really making a difference?
Yeah.
And also it's probably worthwhile exercise trying to run the numbers to see does it make sense adding a GPU, which obviously costs a lot of money in certain circumstances, versus how much extra cores do I need to provide the same kind of user density. I think it'd be an interesting exercise to see if I need 25% more CPU, how much does that cost to provide that compared with adding a CPU into the mix.
Yeah,
Neil, come to Eric Borner's session. He has some tools he'll talk about where he's measuring click to photon. What you're asking for is click to photon, NVIDIA calls it. What that is essentially measuring when I click that mouse to when that response is all the time. It's really hard to measure, right?
Yeah.
It's really important to NVIDIA to be able to measure that variable. And he's got some tools that he can show you around. I'm not sure if he's going to make them public, but there are tools that actually can put a monetary value on that round trip latency and how much of it you can reduce it.
Yeah, and it's even harder, right, when you're dealing with remote display protocols as well, because it's not just the GPU rendering of the graphics. You've also taken out the encoding, and then you've got it.
It can be, but they've come up with a software solution method that now can actually measure it to make it not harder. So,
right.
But definitely, if you guys want to hear more about that, Eric Board doesn't detail.
Yeah, because there you have the half facts. I can stand here and say that it's perceived better, but you have to trust me on that. Yeah. So it all comes down to somehow measure this. And latency is or the responsiveness. I don't know if that's even a word, but that would be one factor of it.
The raw number is about 30 to 40% better experience is what we measure just adding a GPU experience. When you're using the NVIDIA encoder, it's a lot faster to actually encode the CPU. Yeah. It's already there in the frame buffer, so it doesn't have to go far. And so we can increase that overall user experience by a measure of somewhere between 30 to 40%. So we can show you the data, and he's going to have that in session.
I better watch it. We have a new policy, Claire. The tape shoot up with duct tape if you only shoot times.
I will not. Of course, user experience is also dependent on the environment not being utilized or overutilized. So as soon as you hit the roof, the 100% of the CPU load, the user experience drops down significantly, of course. So a lot of factors are indicating the user experience.
So also have to be careful looking at the frame rate counters as well, because if the server is CPU starved, then the frame rate will drop because the encoder won't have enough CPU to keep up that level of frame rate. So it's kind of like, is the frame rate dropping because of the graphics side of it, or is it dropping because it doesn't have enough compute to maintain that level of the frames per second? So.
And there's also picture quality.
Yeah.
That's also a factor to take into consideration.
Lots of variables.
So, other questions or comments? Okay. Thank you for